There are also drugs which inhibit thromboxane A2 production or the function of thromboxane A2. We have thromboxane A2 synthase inhibitors, as well as we have thromboxane A2 antagonists, which prevent the function of thromboxane A2. But most importantly, a good way to inhibit inflammation or stop promoting inflammation is by inhibiting the main enzyme involved in the production of all this, which is cyclooxygenase. So a treatment that can be used is by using glucocorticoids. So lipocortin can inhibit cyclooxygenase and therefore inhibit the production of all these inflammatory mediators. Now let's talk a little bit more about cyclooxygenase. There are about 2 to 3 forms. The third one is not really sure yet, but there's definitely 2. There's cyclooxygenase 1 or COX-1, which is constitutive, which means that it is always functioning, it is always there. There's also COX-2, cyclooxygenase 2, which is inductive. It occurs during inflammation mainly. So COX-1 is always there, COX-2 is there to promote inflammation or during inflammation. Another drug that inhibits the enzyme cyclooxygenase are the NSAIDs, the non-steroidal anti-inflammatory drugs. And these are the most common, and many people take it. It's things like ibuprofen as well as aspirin. They have anti-inflammatory, antipyretic, and analgesic effects. All NSAIDs, all non-steroidal anti-inflammatory drugs, work by inhibiting the COX enzyme, and thus the production of prostaglandin and thromboxanes A2. A newer type of drug which is available in the market are the COXIBs, which specifically work by inhibiting the enzyme COX-2, so cyclooxygenase 2, which is the inductive one, which occurs during inflammation. So now we know the pathway from arachidonic acid to prostaglandins and thromboxanes through the enzyme cyclooxygenase, and what drugs can be used to prevent the production of these or the function of these inflammatory mediators. Now let's follow the second main enzyme, which is lipoxygenase. There are a few lipoxygenase. There is 12 lipoxygenase, there's 15 lipoxygenase, and there's 5 lipoxygenase. These are the main ones. Specifically 5 lipoxygenase, because 5 lipoxygenase is what produces the leukotrienes, which is one of the main inflammatory mediators in our body. So arachidonic acid can be converted to 12-HPETE by the enzyme 12-lipoxygenase. 12-HPETE is unstable and will quickly convert to 12-HETE. And 12-HETE will cause inflammatory actions. Now, the difference between the two is that one has a hydroperoxy group and the other has a hydroxyl group. Arachidonic acid can also convert to 15-HPETE by the enzyme 15-lipoxygenase. 15-HPETE would then quickly convert to 15-HETE. The difference, again, being that the first had a hydroperoxy group and the second had a hydroxyl group. Now 15-HETE can convert to lipotoxin A and B by the enzyme 5-lipoxygenase. Now lipotoxin A and B are interesting because it has sort of an anti-inflammatory effect. Now they act on polymorphic nuclear leukocytes, neutrophils, to oppose the action of pro-inflammatory stimuli. Thus it acts like a stop signal to inhibit inflammation. So it's a bit strange because all the other molecules promote inflammation, but this sort of suppresses inflammation. So continuing on, arachidonic acid can also be converted straight away to 5-HPETE by the enzyme 5-lipoxygenase. 5-HPETE has two pathways. It can convert to the 5-HETE and thus can have inflammatory effects. Alternatively, 5-HPETE can convert to leukotriene A4. Leukotriene A4 can be hydrolyzed to form leukotriene B4 by the enzyme hydrolase. Leukotriene B4 acts as a chemotaxis in the inflammatory response. Leukotriene A4 can also convert to leukotriene C4 by the enzyme glutathione S transferase. Leukotriene C4 can then convert to leukotriene D4 by gamma glutamyl transpeptidase, and an acid was removed. And then leukotriene D4 can convert to leukotriene E4 by the enzyme dipeptidase, removing a glycine group. Leukotriene E4 can then finally convert to leukotriene F4 by the same enzyme, gamma glutamyl transpeptidase. An acid is added in this case. So these are all leukotrienes. Of course, some of these can convert back to its previous one, such as leukotriene F4 can convert back to leukotriene E4 by removing a gamma glutamic group, and then leukotriene D4 can convert back to leukotriene C4 by adding a gamma glutamic group. Now it's pretty simple to remember the leukotrienes because you can think A4 goes to B4, then A4 goes to C4, D4, E4, and F4. The leukotrienes C4, D4, E4, and F4 are important in the lungs. So when we think of these leukotrienes, we think of the lungs. These leukotrienes are particularly important in asthma, for example. They cause constriction of bronchial muscles, and they also cause vasodilation of most vessels, but for the coronary vessels, they cause vasoconstriction. So if these leukotrienes work on the lungs to cause bronchial constriction and therefore this asthma effect, there are drugs available that will prevent these leukotrienes to attach to the receptors within the lungs. These drugs are known as leukotriene receptor antagonists, simple enough, and they work by essentially binding onto the receptor and preventing the leukotrienes to attach to it, thus preventing bronchial constriction and therefore the asthma effect. Other drugs that can prevent the formation of these leukotrienes are the 5-lipoxygenase inhibitors, which essentially inhibits the enzyme 5-lipoxygenase. But by using 5-lipoxygenase inhibitor, it will also prevent the formation of lipotoxin A and B. And as we know, lipotoxin A and B has sort of an anti-inflammatory effect. But it doesn't matter because this 5-lipoxygenase inhibitor will essentially prevent the formation of all these down the bottom, the leukotrienes, essentially. And that concludes this video on arachidonic acid metabolites and the production of the inflammatory mediators, the prostaglandins, leukotrienes, and the thromboxanes. Hope you enjoyed it. Please like, share, subscribe. Thank you.